Hello everyone, in this video we will be covering section 3.1. We will be focusing on reference angles, which we kind of talked about this before. So remember, the reference angle is the angle that you make with the x axis, okay, not with the y axis but with the x axis. And the point of the reference angle is that's the angle you're going to use to actually find the trigonometric values. So for the angle, we're going to use theta. So theta is usually the angle that people are asking you for. And theta either with a hat, sometimes the notation is theta hat with R. This is going to mean the reference angle, okay? And you see that the reference angle is going to be very, very useful. If you are in the first quadrant, theta and theta hat is the same thing. So for example, if this is, let's say 45 degrees, then for this particular case, theta is 45, and the reference angle is also 45. So in the first quadrant, the angle and the reference angle are the same. But if you're in the second quadrant, third or fourth, and so forth, but let's focus on the second quadrant. So you're in the second quadrant, and let's say the angle goes from here to here. And let's say that this part is 140. So this is 140 degrees. Then this will be theta. And the reference angle, so theta hat with the R, is going to be this value, whatever you need to make 180. So in this case, the reference angle will be 40 degrees. Why? Because 140 plus 40 will give you 80. So if the angle is on the second quadrant, it's technically going to be 180 minus whatever the angle is to figure out the value. Okay? If it is in the third quadrant, so you are here, then let's say that this is the angle, it goes from here to here. So for this one, let's say theta is the angle, and let's say theta is 250. Then the reference angle, theta hat, is going to be whatever you went over 180. So after here, this is 180. 250 is how much more than that? So in this particular case, if you are in the third quadrant, this is going to be the angle minus 180. So this will be 70 degrees. Now, I already mentioned this before, so what's the point of the reference angles is that, for example, you want to find sine of 250 degrees, you essentially will find sine of 70 degrees, which you should be able to find. And since this is on the third quadrant, remember that here you have all students take calculus. So on the second quadrant, not third quadrant, sorry, sine will be negative. So this will be equivalent to finding sine of 70. And you just make sure that the angle is negative. All right, so just to recap here, if you are in the first quadrant, so in the first quadrant, theta and the reference angle are the same. If you are in the second quadrant, the reference angle is going to be 180 minus whatever theta is. If you are in the third quadrant, it's going to be the reference angle is going to be whatever the angle is minus 180 degrees. And if you are in the fourth quadrant, the reference angle is going to be 360 degrees minus whatever theta is. So this is the only one we haven't done. Let's say you have an angle that goes all the way to here. And again, it's very important to understand that the reference angle is always done with the x-axis. So let's say that the blue angle is 320. So therefore, from here to here is 320. So therefore, this part is going to be 360 minus 320. So theta hat r, the reference angle, is going to be 40 degrees. Also, recall before we try to solve some problems, this is important. For example, if, so recall this, if sine of theta is equals, for example, to 1/2, that implies that theta is equals to sine inverse of 1/2. And usually here, the angle you're trying to figure out is theta. So therefore, when you do the inverse, essentially what you're getting is not theta, you're getting the reference angle. So in this case, theta hat is actually 30 degrees. Now, since this one is telling you that sine is positive, there is essentially two places where theta could be. If it is in the first quadrant, so that's why they had to tell you which quadrant you were in. So if theta was on the first quadrant, then that means that theta is 30 degrees. Because remember, for the first quadrant, the reference angle and the angle are the same. But if theta was on quadrant, let's say number 2, so then theta will go from here to here. The reference angle will be 30 degrees. So that means that theta will be 180 minus the reference angle, which is 30 degrees. So therefore, theta would actually be 150. And this is essentially what we're trying to figure out. All right, so let's do an example. So the question says find theta if tangent theta is equals to 0.87. For this, make sure the calculator is in degree mode. Okay, so the mode, make sure that is degrees. Okay, so this is for the calculator. So just check your calculator, make sure it's in there. Now here, they're telling you the tangent theta is 0.87 and the theta is on the third quadrant. So therefore, the angle that you're trying to find has to be here. And when we use the calculator is going to give you the reference angle, but the reference angle is going to be this part. So this is what you're going to get. So theta hat r, that's what you're going to get from the calculator, because the 0.87 is not a precise number. All right, so therefore, the first thing you're going to do, remember that if tangent of theta is 0.87, that means that theta, and remember this is going to be the reference angle, is equals to tangent inverse of 0.87. Right, so you use a calculator, make sure that this is on degrees mode. Then the answer is 41.02 degrees. So let's round this to 41 degrees to make things easier. So clearly that's not the angle from here to here, that's just the reference angle. So in our case, this is telling you that this one is 41.0 degrees, or let's just say 41 degrees. So therefore, theta, the one you want, which is on the third quadrant, is going to be 180 degrees plus the reference angle. Where the reference angle, we just found it to be 41 degrees. So therefore, theta, what you really want, is 221 degrees, and that will be the angle from here to here, 221 degrees. All right, so please note, let me just make a small variation in this problem. Please note the following. What about if the problem was this, the tangent theta is equals to minus 0.87, okay? and theta is on the second quadrant. The reference angle is not going to change. Using the information from the previous problem, the reference angle is still going to be 41 degrees. But since we're in the second quadrant now, so the angle that you need is this one. So this will be theta. And remember, this will be the reference angle. So if this was the case, if theta was in the second quadrant, then theta now will be 180 degrees minus the reference angle, which in this case, it was 41 degrees. So therefore, the answer will be 139 degrees. All right, let's try another example. Let's say the question is asking to find theta, same question as the previous one. The information is different if cosine theta is 1.85. Now, notice that the calculator doesn't have cosine inverse or sine inverse. Cosine inverse or secant inverse or cotangent inverse. So therefore, the first thing you have to do is to change this into sine. Remember that sine theta is the same thing as 1 over cosecant theta. Okay. So therefore, all you have to do is use this identity. So this is cosecant theta. So in our case, this will be 1 over 1.85, which happens to be 0.54. So therefore, theta, which is going to be the reference angle, is going to be sine inverse 0.54. So you use the calculator, you will get 32.68 degrees. So let's say 32.7 degrees. Now, since theta is on the second quadrant, that means this is theta. And then for the reference angle, which we just found, this will be the reference angle. So theta hat R is going to be 32.7 degrees. So therefore, if you want theta, it's going to be 180 minus 32.7, which is 147.3 degrees. And that's it. So you can see this is pretty straightforward. All right, so finally, let's do some examples with the special triangles that we have done multiple times. So that should be a little easier to do because we have done them before. So let's try that. By the way, for these ones, you can also technically use the calculator, but the questions for this particular questions, they usually ask you to find the answer or the exact solution. So therefore, that technically means do not use the calculator. Now, remember that we have two special triangles, and the special triangles was this. The first one was the 30, 60 degrees, which for that one, this is 1, this is 2, this is radical 3, and the other special one was the 45 degree, where this is 1 radical 2, and I did mention we will be using this many times. Okay, so in this particular case, this is telling you that theta is on the second quadrant. So this is essentially like the previous problems we did, except they want the exact answer, which means there is no calculator. And to find the reference angle is going to be either 30, 60, or 45. So like this. This is already telling you that sine is radical 3 over 2. Actually, I meant the third quadrant, not the second quadrant. So this is in the third quadrant. So theta goes from here to here. So that's theta, and that's what you want to figure out. But remember, the reference angle is just this part, which again, the reference angle is going to be one of these three choices, okay? All right, so therefore, you look closely, which sign gives you radical 3 over 2. Forget about the minus sign. Remember, this is minus because it's in the third quadrant. So therefore, notice that sine of 30 degrees will be 1/2. So therefore it's not 30 degrees, but sine of 60 is radical 3 over 2. So therefore, from here, this implies right away, from here, that the reference angle for this particular problem has to be 60 degrees. So therefore, this is 60. Since you are on the third quadrant, remember theta is equals to 180 plus the reference angle, which in this case, it will be 180 plus 60 degrees, which will be 240 degrees. And that's it. So you can see this is easier because you don't have to rely on the calculator. And for these particular problems, if it is related to the special triangles, the answer is always going to be 30, 60, 45, 45 for now. All right, so similarly, let's do this problem. Here you have tangent of theta is equals to -1. Remember, you should not be concerned too much with the negative sign. You should focus that this is 1. First, the angle is in the 4th quadrant, so this goes all the way to here. So that's the angle. So this is theta. So the reference angle is going to be this. So the question is, which angle has a tangent of 1? And then you go to the special triangle, which is this one right here. Notice that tangent of 45 is 1 over 1. So therefore, from there, that implies that the reference angle has to be 45 degrees. Why? Because of this triangle. If you memorize those values, that will make life even easier. So therefore, since the reference angle is 45, and you're in the 4th quadrant, remember theta is going to be 360 degrees minus 45 degrees, which is the reference angle, and this will be 315 degrees. And that's it.